Okay.
Jawad, the entire 7th period class.
Alright, so it's just Lauren. Okay. Is Lauren here today? Is anybody seen her?
No, I don't think she is.
Not good. Okay, what we're going to do is make sure you have last night's assignment, get that out. And then we're going to continue with it. So bring these up. Is there any of these that you would like to see before we really get into it? Everybody's comfortable with all of this? Are there any of these that you'd like to see? What?
Will you do just some random ones so I can see
Sure.
if I'm right?
We'll do a couple of different ones here. Let's just go ahead and try cosine of 5 pi over 4. So, again, how many circles have we drawn this week?
A lot.
Yeah.
I like your big one the best.
Yeah, you should all be drawing circles on all these. So 5 pi over 4. It is a pi over 4 reference, which is how many degrees? 45. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So it is a 45-degree reference, which means your coordinate is square root of 2 over 2, square root of 2 over 2. You are in the third quadrant, which means what? They're both negative. And cosine is your x value. So it is the negative square root of 2 over 2.
Yes.
Okay, good. Another one. Let's go ahead and do. How about this one? Cosecant of 7 pi over 3. Okay, so we have a pi over 3 reference, which is how many degrees? 60. So again, we're going to draw a circle. We have 60 degrees, and another 60 is 120, so that's 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. So we're at 60 degrees, right? What is that coordinate? Very good. Very good. All right. What's the sine stand for? Oops. What's cosecant stand for? So if you look at your
Man, I did that wrong.
reciprocal of the sine, right? Or reciprocal of whatever your y coordinate is. So reciprocal of square root of 3 over 2 is 2 over the square root of 3. Can't leave it like that. You need to rationalize your denominator. And you get 2 square root of 3 over 3 for your answer.
Yep.
Good? And you do have the answers in the back of the book for those, so you should have known if you got it right. 13B, I sure can. Secant. So now we have a negative. So which direction are we going when we use circle? We're going to go down to start with, and it's a 60-degree angle that we're doing. So we go down to 60 degrees. So what is this in terms of pi going the other direction? Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. I'm just asking. So what is that coordinate? It's a 60-degree reference. Right. Okay. So what does secant go with? Cosine. So it's the reciprocal of cosine. Cosine is your x value, so the reciprocal of the x, so this answer would be 2. Awesome. Any others? How are we doing?
I'm bad, but it's okay.
Okay. Ready to go on?
Yeah.
Awesome.
I guess.
That's a good warm-up. Okay, here we go. First of all, put on your formula sheet your Pythagorean identities. Okay? Yeah. A little bit smaller. Quickly write them down.
Wait, what things am I gonna do?
Pythagorean identities. We're going to use these today here in a little bit. Y squared plus x squared equals 1. That's just your unit circle formula. Okay? Write faster. You have it in your book. You can write it down.
Wait, I'm gonna take a picture.
Write faster. Let's go.
Let me do.
What's after the cosecant?
T.
T. Oh, T. Oh, not it.
You already moved you.
Okay. So let's take a look at this stuff right here. Find the value of each of the 6 trigonometric functions. So what we've been working on so far is really 30, 45, and 60 degree coordinates. We haven't been talking too much about the x-axis and the y-axis. And there's a good reason for that. So now we're at problem number 23, and they're introducing those coordinates. So when t is 0 on your unit circle, you are right here, right? You haven't started yet. You haven't started going up yet. So what is this coordinate?
1,
1, 0. Okay, now, and what's the 6 trigonometric functions? So the sine value, which we know also as what? X or y? Y. So the y value is 0. But here's the thing, you need to think about this in terms of a fraction, because you're going to be taking the reciprocal of that for the cosecant. So the cosecant of t needs to be the reciprocal of this. Well, what was this? The sine is the opposite leg over the hypotenuse. What is the hypotenuse? What's the value of the hypotenuse? 1. So really this was 0 over 1. Okay? So the cosecant is going to be the reciprocal, which is? 1 over 0, which is? Undefined. Okay? All right, and then we go to, we do cosine. Cosine is what? The x value. And again, you need to think of it as a fraction. It is the adjacent leg over the hypotenuse. Again, the hypotenuse is 1, so really this is 1 over 1. The reciprocal identity is the secant. The secant then would be the reciprocal, or 1 over 1. You with me? Now let's do tangent. The tangent is what as far as y and x are concerned? Y over x, right? Or we say the opposite leg over the adjacent leg. All right, so let's think about this. The opposite leg, there isn't one, right? So y is gone down to 0. The opposite leg is 0. And your hypotenuse and your adjacent leg are the same thing at 0, okay? So the opposite leg is 0. Your adjacent leg is 1. It's the radius. So this is 0 over 1 or 0. And since we're at the fraction here, the cotangent is then undefined, 1 over 0. And this is very important, guys, for later on when we start to do graphs. Understanding where something's undefined is usually an asymptote. Okay, so we need to make sure we get this. Now, it doesn't come into play right now, but you got to be able to figure this stuff out. But that's the reason it's number 23 and not number 5 in your homework. Okay, so now let's do number 24. That was your first homework assignment problem. 24, where's pi over 2?
90.
At 90 degrees. Okay, so we're up here. I'll just use this picture here. So what is that coordinate?
0, 1.
So 0, 1. Okay, again, everybody do this on your own. Sine, cosecant, cosine, secant, and tangent, and cotangent. Everybody figure out what those are. And we'll see if you get it right. Done, right?
No, hold on.
Alright, I'll do the easy ones. Y value is 1, cosine is 0. Tangent is y over x, 1 over 0 or undefined. Okay? Cosecant is the reciprocal of this, which is 1. Secant is going to be undefined, 0 over 1. Cotangent is going to be x over y, 0 over 1, or 0.
Wow.
We got them all right.
I now remember this.
Okay, let's do one more. I'm not going to do all 4. I'll do another one of your homework assignments, okay? Let's do number 25. Where are we when t is to pi?
180.
180. Okay, so we are right here at pi. What's that coordinate? -1, 0. Okay. What is the sine value? We'll do it
Sine
together.
is y.
Which is
0.
0. And then the
Undefined.
cosecant
Undefined.
is going to be the reciprocal or undefined. Okay, then you have the cosine, which is
X.
x, which is -1, and then the secant then would be,
0. I don't know.
what's the reciprocal? Still -1.
Oh. What?
This is -1 over +1. It's still 1 over -1, which is -1.
Oh.
Okay. So now the tangent is sine over cosine, y over x, sine over cosine. 0 over -1 is 0. Cotangent for 0 over -1. What's the cotangent? Undefined. -1 over 0.
Are they all going to be on one of the axes?
What, the undefined part?
No, like all problems are they going to be
These
on one
are,
axis?
just these 4.
Oh.
Okay, so watch what happens when we look at the next set of problems. So look at this chart. It's the exact same thing we just got done doing, just written in a chart form.
Wow.
I don't know. I don't know why. I just want to show you that it was really kind of silly that they did that. But you might see it again sometime.
Oh no, I didn't. Oh.
Okay, now this is the easy part of the assignment. It's just to make sure that you really understood what it is we've been saying this whole time with your trigonometric functions and their identities. So when sine is y, cosecant is 1 over y. Okay, or the cosine is x, and then you understand that that's what those things are. It wants just sine, cosine, and tangent. That's all it wants. So if I look at 28 here, the sine, cosine, and the tangent of t. What's the sine value? That's just the y value. Square root of 3 over 2. What's the cosine? -1/2. And what's the tangent? Well, how do you find it? You put y over x, which is kind of how we have it set up here. So what you do is you take the top value, square root of 3 over 2, times the reciprocal of the bottom, reciprocal of x. And you get negative square root of 3, don't you? That's all you're doing on these sets. Yeah, that's easy. Can you do that?
Yeah.
Yeah. It's not all difficult, guys.
Are we doing on the same paper?
Yes. Okay, let's look at the next set of problems.
There's a next part.
Oh, there's a whole
What
bunch.
is it?
There's a whole bunch.
Why do you
Everybody take out your handy dandy graphic calculator.
You have to actually use it.
Yeah, for a brief moment.
I like. Is this the one that has to be on radian?
Huh?
Is this the one that has to be on radian?
Right now, put your mode in degree mode. So go down to the third line and hit degree, highlight degree. And so what I want you to do, this is 30 degrees here. So if I take the sine of 30 degrees, I'm using degrees. So I need to be in degree mode. What is the sine of 30 degrees? This is what we talked about the other day. 0.5. Okay. Now, if I want to know, so 0.5 is how high it is, right? It's the y value of that coordinate. That's this piece right here, all right? This is what we call radians, the actual distance around the circle. Right? If we go all the way down over here, this is 3.14. Okay. So if I want to know what this distance is, 0.1, 2, 3, 4, 5, this probably isn't quite right. If this is 1/2, this has got to be a little bit more because it's curved, right? Okay. So the sine of the radian measurement, whatever that is, should equal 0.5, should equal 0.5. Because it's still going to give me the y value at that point. If I take the sine of 30 degrees, it gives me the y value. If I take the sine of the radian measurement, it gives me the y value. Sine is the y value at that point.
It doesn't.
But, well, it's because you're not in radian mode, and you're not doing it right. That's what I did the other day. So to get r, I need to get the sine over here. How do I move that over there? What do we do? Arc sine, or the inverse sine of 0.5. So now you're looking for radians, put it in radian mode, and do the arc sine of 0.5.
Oh, you want a 0.5.
And what do you get?
0.5, 2, 3, 5, 9, 8, 7, 7, 5, 6.
If you wanted the degrees, you'd have to be in degrees, and you take the arc sine of 0.5, it'd give you 30 degrees. Okay? You'd have
You
to be
really
in,
goofed up the other day.
you'd have to, I was just screwing them all up. You're not doing this here. I was just going to show you that that's what radians are. But we are going to do more things where you have to switch back and forth between radian measurement and degree measurement. So here's how you know. If you're dealing with radians, be in radian mode. Okay? Notice these don't have degree symbols on them. So these are all radian measurements, so you need to take the radians out, or put it in radian mode. Now, here's the two parts that you're doing in this set of problems. One, you're going to approximate, you're going to guess what the answer is, and then you're going to use your calculator. So how do you guess? Let's make a really good guess. If we're on number 38, 0.8, so we go up the calculator, or up the unit circle, 0.8, 0.1, 0.2, 3, 4, 5, 6, 7, 8, right here. So if I want this coordinate, I need to know the x value, and I need to know the y value. Okay, so it looks like my x value is 0.7, and my y value, I have 0.7. Now, it's not asking for both of those. This one, it just wants to know the x value. So I'm assuming it's 0.7. So this is part A. Part A, approximate. So I find where I'm at on the radian measurement, and then I either look for the y or the x, or both of them if I'm going to do tangent. Okay? And I'm approximating. My answer is going to be 0.7. So I take my calculator for part B, and I actually take the cosine of 0.8 in radian mode. And what do you get? 0.69 something. Okay? 0.8. What? Do it again. Cosine 0.8. You have 0.64 again?
No.
Oh, you got 0.69?
Yeah.
You must have added a button or something. Okay? That's what you're going to do on these. That's easy, right?
Yeah.
Okay. Nobody's complaining yet. Right? Mara?
I just want you to stop there so I can do my homework.
No, we got a lot to do.
Oh, there's
Next
more.
set. Oh yeah, there's a lot more.
Why?
How much more
Sine of trigonometric expressions. Find the sine of the expression if the terminal point determined by t is in the given quadrant. Okay. So here what we're doing is we're doing operations. with values, positive and negative values. So let me ask you something first. What is sine y and what is cosine x? All right. What are x and y? What's the y value in quadrant 2? What's positive or negative? Positive. And what's the x value in quadrant 2? Negative. What is positive times a negative? Negative. There's your answer.
What?
We're working up to stuff, so you gotta start with some baby things. Okay?
You keep doing big things. I like that.
Tangent is y over x. What's the secant? Over x. So we're in quadrant 4. What is the x value in quadrant 4? Positive. All right, so here we have positive and a positive. Now what's the y value in quadrant 4? Negative. What is a negative over a positive? Negative, and 1 over a positive is positive. So we have a negative times a positive, which is negative. So the tangent times the secant is going to be a negative value when you're done. It's just practicing understanding what your values are. That's all it is. All right, so you can do the rest of those. Let's go down to the next thing. How we doing? It's easy so far, isn't it?
Yeah.
All right, good. Great. Same type of thing here. Y, let's do 50. We'll do 49 and 50. Y is, what's this mean? Great. What values are bigger than 0? Positive values. So y is positive. X is negative, right? So if y is positive and x is negative, what quadrant am I in?
2.
Yeah, second quadrant. Okay, quadrant 2. Okay, so far? Okay, tangent is y over x, right? Tangent has to be positive. So how can this be positive? When they're both positive, right? Or if they're both negative, right? Alright, so first of all, what quadrant are we in if y and x are both positive? Quadrant 1. Where are we if y and x are both negative? 3.
Oh.
How do we know which one? By the next clue. The y value is negative. So if y is negative, we have to be in the fourth quadrant. Or third quadrant, thank you. So we're in the third quadrant here. So you do have to think about these. That's the purpose. Forcing you to make sure you really understand the values as you're going through the problems. What did I tell you at the beginning? You got to make sure you know what quadrant you're in and the value of what it is you're dealing with. It's not that you can't do it. You got to think about it. Okay? All right. Next set of problems. I've already done some of your homework for you. Aren't you happy?
Yay.
Now the hard part. Now you need those formulas. Pythagorean identities. Those theorems. Okay, let's take a look at 53. Here's what you need to focus on. There's 2 things up here in each problem. You need to focus on the first thing. It's the sine. Here's the first thing you do. You find one of those 3 Pythagorean identities that uses sine. Which one is it? The first one. So what is that? Good. So the first one that you have in your column here, that's what tells you which Pythagorean identity to use. Got it? That's the first thing you do. Second thing you do is you need to solve it for this. So don't look at these yet. Don't look at that. That doesn't mean anything yet. So now solve that Pythagorean theorem, Pythagorean identity, for this first trigonometry expression, sine. How do we solve for sine? How do we get sine squared by itself? Subtract. not asking anything difficult here. We're not mixing chemicals. Sine squared t equals 1 minus the cosine squared of t. We all good so far? Just algebra, manipulating the expression, the equation. Okay? Step 1, find the trigonometry Pythagorean identity that you're using, and then solve for whatever it's saying, okay? So now we solved for sine squared. I need sine. How do I get rid of the square? Square root. And when you take the square root, you get positive or negative square root of 1 minus cosine squared of t. Now that's sine of t. You solve for sine of t. Step 1, use the Pythagorean identity. Step 2, solve for whatever this is. Step 3, whatever it's equal to has to have just that Pythagorean trigonometric function. And that's all it has. It only has cosine on the right side. It can't have another trig function with it. It can't have tangent with it or secant with it. It can only have whatever's in the second position. And that's what this has. It only has cosine on the right side. Okay? 1, pick your Pythagorean identity. 2, solve for that one. 3, make sure that's the only thing that's on that side. You'll see in a minute that it won't be. You'll have to change it. Step 4, we're in quadrant 2. I don't care that the cosine is negative in quadrant 2. We're writing this about the sine. Sine is what in quadrant 2? Positive. So this better be a positive answer. Even though you're saying this is cosine, you're using this substituted in for sine, and sine is positive. Okay? So everything depends on the left side, the very first thing given. That's what it depends on. All right, now that was the easy one. Well, I need to use an easy one to do the steps, all right? All right, let's do hard. Tangent and sine of t. Because this one's just the same thing, just the other direction. Okay? Tangent, sine of t. So tell me which function or Pythagorean identity we're going to use. Huh? What is it? Good. I wasn't sure what it was. Okay. What's step 2? Solve for tangent. Okay, so what am I going to do? Subtract 1. So now I have tangent squared of t equals secant squared of t minus 1. Alright? Now I haven't solved for tangent though, have I? What do I got to do? Take the square root and you get plus or minus. So the tangent of t is equal to positive or negative the square root of secant squared of t minus 1. Okay, so we are in fourth quadrant. What is the value of tangent in the fourth quadrant? Tangent is y over x, so you have both y and x. What's the value if you have y over x in the fourth quadrant? What are your y values in the fourth quadrant? Negative. What are your x values? So what is a negative over a positive? Alright, so this is going to be negative. Now, typically we'd be done at this point. Except we don't have sine on the right side. But what do we know about secant? Huh? 1 over what? What is it? I'm not trying to trick you. I'm wanting everybody to participate here. What does secant go with? Cosine. So this is 1 over cosine squared of t minus 1. And you say, well, wait a second, that's still not the sine. And this gets really ugly. Okay? So now what do you know? How do you know how can I get sine back in here from cosine? And that's what we were doing here. And what you were doing here if you were to do 54. So if you have sine squared plus cosine squared, oops, and I want to substitute cosine squared with something with sine, I need to move the sign over here. This is really 1 minus sine squared of t, isn't it, in the denominator? Yes, you have to use all these Pythagorean identities to switch them. Sometimes you're just going to flip them over and you'll get the function you want. Sometimes you have to manipulate the Pythagorean identity to get what you want. Cosine squared is equal to 1 minus sine squared, isn't it? And therefore we have sine on the right side. But we have a disaster. I'm running out of room. I can't put it over there because of the camera. So what this is minus. This is the next step from here, okay? 1 over 1 minus sine squared of t minus 1. Now, it'd be great if we were done, but we're not done. You gotta combine this.
Yeah, Mara's completely lost.
Okay. Alright? So, 1 is the same thing as 1 minus sine squared of t over 1 minus sine squared of t. From the beginning of the year, I told you you need to remember what 1 is. 1, as a fraction, is anything you want it to be over itself. So in order to combine fractions, I need the same denominator over here as I had over here. This is ugly. This is a bad one. But it's not like you can't do it. I'm not done. I'm not done.
I'm still
Look, Monday you guys felt like you were in the ocean with no life preserver, right?
I still feel that.
Okay. And then you started catching on to some things, right?
Yeah, now we're back.
Huh?
We're back in the ocean.
Now you're back in the ocean.
Popped.
Somebody popped your inner tube. Okay. All right. Well, that's all right. You'll get past this too. Okay. Now I can combine these. I'm gonna write this over here. Negative square root. Now you got to distribute this minus sign through this part. Now watch what happens. We'll just kind of do this on the fly. 1 minus 1 is 0, and then a minus is. So this is positive sine squared of t on the top. On the bottom, I have 1 minus sine squared of t. What? Yes, and again, I'm trying to get you guys to say something, but that's all right. We'll get to it eventually. We're just taking a few extra steps. Wow. Okay. What's 1 minus sine squared of t? We're going backwards here. What's 1 minus sine squared of t? Cosine squared of t. Okay. I wanted you guys to say something. That you had a cosine squared of t on the bottom. We can take the square root of the cosine. You can't have a fraction inside your radical. So you gotta keep working this until there's nothing down there. So you have a negative. What's the square root of sine squared? Sine. Square root of cosine squared? Cosine. Except we need this in terms of sine, which is 1 minus sine squared, and you take the square root. And we're going to stop there because I don't want to keep going and keep going around and around. I want you to do the first 4 steps. And then change it so it has the right function in it and stop at that point. Because some of these get really ugly. Let's do another one.
How far did we go?
Was that 4?
Oh, that was past 4.
Okay.
That was like,
Yeah. So let's do another
that
one.
was like 8 steps.
Let's do another one of your problems. Relax. What's step 1?
Gotta find the one thing that.
Okay, tell me what it is. Mara's gonna do this one.
No, because I'm gonna cry. It's on camera.
Just say somebody else's name.
What thing I'm supposed to do? I don't know how you figure out which one you're supposed to use.
Which one has secant in it?
The tan one.
Tell me what that is.
Tan squared t plus 1 equals sec 2.
Secant squared.
Sec.
Okay,
At least I
what's the
know.
second step? You remember?
Don't you have to? Well,
Solve for it. You gotta solve for secant. So how do I get secant from secant squared?
put on the other side.
Now how do we get rid of the square?
Oh, you're square.
So now you have plus or minus, and this is gonna just be secant, which is what we wanted. In terms of tangent, which is what we have, we are in the second quadrant. So what is the secant? What is secant? X or Y?
X.
X. What is X in the second quadrant? Negative. So this is gonna be negative, you're done. Because you don't have a fraction.
That was so
Yeah,
much
that's
more simpler.
Huh?
That was so much more simpler.
Yeah.
But I'm so confused.
Simpler. Exactly.
Why do you put sine on the other side of the thing?
Yeah.
We just came from walk around.
We had to
Yeah,
get rid of
no,
cosine.
screw Walker.
So you had to substitute something for cosine.
I didn't say anything like that.
I don't remember which one
That
that
was
was.
boring.
Want to do another one?
Yeah.
Okay.
Yeah.
We'll come back up and do another one in a minute. I want to do the next set. Hey, so far you said they were all easy except for that one. So relax.
I'm gonna forget it.
This is actually pretty simple. Ready? Number 63, another one of your homework problems. What quadrant am I in?
5, 4.
Five.
I want
I
you,
see the V, I need 5.
I want you to draw, go to that fourth quadrant, and I want you to draw a right triangle. Doesn't matter if it's 30, 60, 90, or 1, or 359 degrees, okay? Just draw it in that quadrant to remind you what your positives and negatives are. The sign represents opposite over adjacent. So you can tell, right? So my opposite leg is -4, which you're in the fourth quadrant, well, I should be negative. And hypotenuse. Opposite over hypotenuse. And your hypotenuse is 5. Don't worry about it being a unit circle thing, okay? Just do what I tell you to do. So you're drawing this, and you're in the fourth quadrant, and you have a right triangle, so -4 over 5. So the sine of theta is the opposite leg over the hypotenuse. Now you use the Pythagorean theorem to get x. Everybody should know what this is. Like 4, 5. Yeah, 3, 4, 5. It's positive because x is positive in the fourth quadrant. Yes. Oh, x squared plus 16 equals 25.
But why
16
5?
from 25 is 9. Square root of 9 is 3. Just do the Pythagorean theorem. That's what you're.
The hypotenuse. Okay, yeah, you're right.
Pythagorean theorem. Okay, now you do this to get the 3 numbers you need to do sine, cosine, tangent, cosecant, secant, cotangent.
Which one? Where the 3 came from?
Find the values of the trigonometric functions. Now watch. First of all, you know 2 of them right off the bat.
4,
Listen.
5.
You know 2 of them right off the bat.
Negative.
They gave you sine, and the reciprocal identity of sine is what? Cosecant. So the cosecant is
5, 4.
-5/4. There, you got 2 of the 6.
6.
Okay, what? Now you did the Pythagorean theorem. What's cosine? Don't say 3. You
Cosine
gotta
is
use
x.
SOHCAHTOA.
Jason over hypotenuse.
All right, the adjacent over the hypotenuse. So the cosine is now going to be 3/5.
5/3.
And what's its reciprocal?
5/3.
Secant.
Oh.
5/3. Now tangent.
Opposite over Jason.
-4/3. And cotangent?
3. Negative 3. 4.
-3/4. Yay. So what do? Go to the quadrant they're talking about, draw a right triangle. And then remember SOHCAHTOA and put the numbers in the correct positions. Do Pythagorean theorem to get the missing piece. and then do the rest of this.
How many questions are in that?
I did 3 of them, didn't I? So, good? All the way to 69.
Too many problems.